Hello, today we will review the extrusion design constraint in Generate. As the name implies, we will create an optimized part that is effectively extruded. This can be useful when designing parts for 3-axis milling. We will use the design space used in the sample project called A-A arm, which is a suspension or control arm used in a car chassis. The final result of this tutorial is shown here in Generate. Let's start a new project and see how to build this optimization. Here we are inside of a new Generate project that uses the design space from the A-arm sample project. Our first step is to create the extrusion design constraint. To do that, we first need to select a face of the design space that is normal or perpendicular to the direction that we want to extrude. In our case, we want to extrude along the z-axis, so we can select any face of the design space that is normal to the z-axis. Next, we need to input a few boundary conditions. If you are unfamiliar with boundary conditions, please watch our Generate overview video, or in future videos we will cover them in detail. Our optimization is finished and we have our final result. You can see the topology result is extruded in both directions to the extremities of the design space. The extrusion constraint has the option to extrude in both directions or in a single direction along an axis. By default, the extrusion constraint is set to extrude in both directions, or a bidirectional extrude. To demonstrate a single direction or unidirectional extrude, we will clone a scenario by clicking the clone button. In the clone scenario, we can edit the extrusion constraint by clicking the pencil icon next to the extrusion constraint. If we disable the bidirectional option and rerun the optimization, you can see how one side of our topology result is cleanly cut off by the design space, creating sharp edges, and the other side of our topology result is smoothly blended. This is a result of the unidirectional extrusion constraint we applied. What type of extrusion is currently applied to the optimization is represented in the 3D viewer by the black vector. If a black vector and translucent vector are visible, a bidirectional extrusion constraint is applied. If only a single black vector is visible, a unidirectional extrusion constraint is applied. The direction of a unidirectional extrusion constraint can be modified by reversing the sign in the vector dialog box for the extrusion constraint. That concludes this tutorial. Thank you for watching and good luck with your optimizations.